Okay, so last section we're going to look at is 7.5, and we'll try to tie it in maybe towards the end with logarithms a little bit. But this one has to do with banking and interest rate formulas. One of the formulas we look at has a variable in the exponent. So we've talked about variables as exponents, and that's when you have to use logs. So we'll see if we have a little time, we'll look at one of the banking formulas, and we'll try to solve for one of the variables that's in the exponent. So we'll have to use something we learned this week. All right, so first of all, just kind of make sure people understand what the idea of interest is. So interest is basically money that you either get paid or pay to someone else for the use of that money. So it can work both ways. If you put money in a bank, the bank then takes that money and lends it out to other people. That's how banks make money. So if you had a large amount of money, like millions, tens of millions of dollars, and you put it in a bank account, you probably couldn't go like the next day and take, or the next week, and get all that money because the bank doesn't have it anymore. They've lent it to other people. Maybe somebody wanted to buy a house, so they lent it out some money to buy the house. Maybe somebody wanted to buy a car, so they lent some of that out to someone else to buy a car. You could get the money if you wanted it, but it may take the bank a couple days or even a week to say, all right, you want to take $10 million, you got to give us a couple days to get that money. Where does the bank get it from? They can borrow it from other banks. So it's just all this borrowing. So in that case, you get paid a little bit of interest because the bank is like thanking you for letting you put your money there, and then they can use it. On the flip side, if you're the person using it, so let's say you take out a loan to buy a house, you're going to have to basically thank the bank and say, hey, for letting me use the money, I'm going to give you a little bit of interest. You don't really have a choice. You got to pay the bank for using their money. And there's all kinds of things you can do, like if you buy a house, some people try to make like extra payments. So if you do that and you pay off your mortgage a little quicker, you can save a ton of money in interest. By ton of money, I mean easily like 5 figures in the tens of thousands of dollars, maybe even 100,000, depending on how much of a mortgage you have. So the money that you borrow, or the money that you're investing, that's called the principal. So if you take out a loan for $150,000 to buy a house, the $150,000 is the principal. And what kind of stinks is when you start paying the bank back the money you borrowed, it doesn't go towards the principal. It goes towards the interest. So what the bank does is they basically figure out, okay, if you borrow $150,000 and you're going to take 30 years to pay that money back, you're going to end up paying back $300,000. You're going to pay back all this extra money in interest. Well, when you start making your first mortgage payment, say your mortgage payment was $1,000, probably over 900 of it would go towards paying the interest off. Then maybe $50 or $60 would actually go towards lessening the principal on the loan. That's just the way it kind of works. But what you can do is if you make an extra payment that month, you can tell the bank, hey, here's an extra $200. I want you to take it right off the principal. So what that does is it lowers the loan amount, and then the next month your interest isn't as bad. So you pay a little bit less interest. But over time, it really helps if you can make extra payments on the principal. So there's different ways to calculate interest. We're going to start with what's called the simple interest formula, and then we're going to build up to the compound interest formula. So the simple interest formula is I equals PRT. This is not the way most banks would calculate interest paid to you or interest you're paying to them. Okay? It's a little simpler than what is actually happening. But the idea is if you want to calculate a certain amount of interest on a principal at a certain rate for a certain amount of time, that's how you do it. It's important when we write the rate that we do it as a decimal. So if you borrowed money at a 5% interest rate, you would want to put R in as 0.05. And time can technically be anything, but we're going to do it in years because when you look at interest rates, the most common way to write an interest rate is annual percentage. That's what A stands for, annual. Now, if it said MPY, which I've never really seen that, but if it did, that would probably mean monthly percentage. So in that case, if your interest rate was a monthly rate, you would want to make sure your time was in months. But interest rates are usually annual, so your time is in years. Okay. So let's just look at an example. So in this problem, we're going to borrow $2,000 at a rate of 6% for 2 years. How much interest do we pay? Now, this assumes we're going to let the loan go to full term, which means we're not going to make any extra payments early. We're just going to pay, you know, the minimum we got to pay each month. No, nothing special. Okay, so we're just going to use that formula and figure out the interest. Okay, so first we just got to make sure we know what number is what here. Lexi, what's the 2,000? In our example, what letter would it be up above? P. That's the principal. That's how much money you're borrowing. What about the 6% rate? It's the rate. And how do we have to write that? Because we can't plug it in as 6%. We got to plug it in as 0.06. So that's my R. And then it says we're going to borrow the money for 2 years. Okay. Well, years, that's my time. Okay. So using simple interest, let's see how much money we would end up paying the bank if this was the situation. So it's your principal times your rate, which is 0.06 times the time. Now with money, we always round to 2 decimal places, so there's no question about rounding because we round to the nearest penny. So we get 2,000 times 0.06 times 2. So if you borrowed $2,000 at a 6% interest rate over 2 years, using simple interest, you would pay back the bank $240 beyond the original amount you borrowed. So you'd end up paying the bank back $2,240. And you could kind of flip that around and look at it the other way. What if you put $2,000 in a savings account for 2 years and it earned 6% interest? How much money would you make? $240. Interest rates are nowhere near 6% in a savings account. You'll never see that. Right now, if you look at the website, these are different savings accounts. The best one I see is 1%. And to earn 1%, you have to have a minimum balance of $25,000. A lot of people probably don't have that. So let's say you could open a bank account. You know what? You say, all right, I got $500 I could put in a bank account. Well, you're going to earn 0.15%. Not that much. So as a decimal, that's 0.0015. Like if we were doing a problem with this number, 0.0015. It's pretty small. Okay, it's not a lot. Sometimes if you get like a checking account, they may have better rates, but you have to do certain things a month. Like they might say you got to get all your statements electronically because we don't want to have to mail anything because that costs money. You got to do a minimum of 10 debit card transactions a month. You also have to have at least one direct deposit. And if you meet all those criteria, the bank may say, all right, we'll give you a better interest rate. And the reason they're doing that is because every time you use their debit card, they make a little money. You know, like if you use it at the store has to pay a fee for you to use a debit card. Like it's not free to, you know, like if I wanted to open a store and accept credit cards as payment, it's not free for me to do that. I got to pay a company to accept my credit card machine, and I got to get it all hooked up. So that stuff costs money. So some checking accounts will do that. I have one checking account that will pay 3% interest. which is really pretty good. But they only do it up to $15,000 because otherwise people would just be putting a ton of money in there if they had it and make a lot. So the bank says, all right, up to $15,000, we'll pay you 3% interest if you do 10 transactions and all this stuff a month. And that's easy to do because if you do like bill pay on the computer, you can just set all that up. So I have at least 10 bills a month I pay. They're all automatic. So I don't even have to think about using my debit card. It just automatically happens every month. But if I put in any money, let's say I put in $16,000, that extra $1,000 that's in there, the bank says we're not going to pay you anything for that. We'll pay you up to $15,000 and that's it. So, you make money on that. If you have more money, maybe you want to put it in another savings account somewhere else. Split up your money. All right. So, compound interest. So this is more how interest really works. So let's say at the beginning of the month, you put $100 in your bank account, just to keep this simple. At the end of the month, you make $1 in interest. Now you have $101 in your bank account. When you start making interest in February, or well, the next month, I was assuming January, but let's just say whatever the next month is. Okay. Now, you're not making interest on just the $100 you had. You're going to make interest on the $100 plus the $1 they paid you. So now it's like your principal is $101. So maybe at the end of that month, instead of making $1 interest, you make $1.05. You make a little bit more interest because you got a little bit more money to start with. That's the idea of compound interest. So it's interest that you make on the money you put in plus the interest that the bank gave you. Now, compounding basically means when does the bank give you the money you've earned in interest? Do they give it to you at the end of every day? So like if I made 10 cents in interest in my bank account today, am I going to see that in my bank account tonight? If so, then that means they compound the interest daily. Some banks may say, you know what, it's too much work, we're not going to add it every day. We'll let you make all your interest for the month, and then the last day of the month, we'll put a deposit in your account for all your interest. Okay, that's how a lot of banks do it. It does work out better for you the sooner they deposit it, right? So like if they wait a whole month and then put it in at the end of the month, that's not as good as if they did it, say, at the end of every week, or if they did it at the end of every day. It's even better. A little better. Not a lot, but a little bit. So we're going to look at an example where this bank compounds quarterly. What that means is you're going to make interest all of January, all of February, all of March, but you're not going to see any of that interest until the last day of March. They'll put a deposit in your account for all the money you made January through March. Okay. So we're going to assume just that this particular investment pays 8%. We're going to start out with $1,000 on January 1st. And I want to know how much money I'm going to have after 1 year. Now, I picked quarterly because if we do this quarterly, we only have to do it 4 times. The end of every 3 months. If I said we're going to do it monthly, we would have to do this by hand 12 times. It's not harder, it's just more of a pain, it would take longer. So what we're going to do is we're going to kind of break it up into quarters. Let's start with the first quarter of the year. January, February, March. First 3 months. Right. So this is going to be the interest from January to March. Okay, and we're using the formula I equals PRT. We're using it 4 times though. That's what makes it compounded. Okay, we're going to do it 4 times. So, on January 1st, how much money is sitting in this account? $1,000. So that's my principal. Principal times my rate. What's the rate here? Yep. 0.08. Okay, and we're going to assume that that's an annual rate. They didn't tell us otherwise, so that's an annual rate. And now my time. We got to be a little careful because the rate was annual, so the time has to be in years.
0.25.
It's a quarter of a year, 3 months, 0.25. So let's do that calculation, and that will tell us the last day in March how much interest they're going to deposit into our bank account. All right, so we got 1,000 times 0.08 times 0.25. So at the end of March, you're going to get a deposit for $20 in interest. That's interest. So now, the next quarter of the year is April. April, May, June. So let's figure out the interest that we're going to make from April to June. Now, April 1st, when you look at your balance in your bank account, it's not $1,000 anymore. What's the balance going to be now? $1,020, because the bank made a $20 deposit for interest that you made the last 3 months. So now you have $1,020. That's your principal. We're going to assume the rate stays the same. Most interest rates change monthly. Okay, but if I start changing the rate every month, that's going to get real confusing. So let's assume that the rate stays at 8% all year long. It's very unrealistic. And then the time, again, April, May, June, that's another quarter of a year.
Instead of doing it all out, can you just take the 8% of $20 and just add it on to 1020?
So you think we're going to make another $20 in interest?
No, but for every month, instead of like doing it all out, couldn't you just take the 8% of the extra $20 you got and add it on to the 1,020?
All right, well, let's try it that way after and see if it works. Let's see if we get the same thing. So now we've got 1,020 times 0.08 times 0.25. 0.25. So this month we made $20.40 in interest. We made a little bit more money because we had a little bit more principal to start with. All right, so Nathan, what was your idea? Take $20. Yep.
8% of $20.
Take 8% of that. Okay.
And divide it by 4 for the quarters.
Divided by 4. And that gives me,
Same.
yep, that gives me the 40. And then add that on to the 20. Yep. So there's several ways to do the same thing. In fact, this isn't really the best way to do compound interest. I'm showing it to you this way to start out, but I'm going to show you a much easier way in a second. All right, the next quarter of the year. July, August, September. So now July through September. What's going to be the balance in my bank account on July 1st? Yep.
$1,040.40.
Yep. So now I have $1,040.40. That's my principal. My rate is 0.08, and it's another quarter of a year. Okay, so we'll do that out and see what we make. Okay, so let's do this out. 1,040.4 times 0.08 times 0.25. So this month, we're going to make $20.81 in interest. The bank's actually giving you a little bit of free money here because technically you didn't make 81 cents in interest, but they have to round it. So they're giving you, because they're really generous, 2/1000 of a dollar for free. Basically getting 2/1000 of a dollar because of rounding. So $20.81. All right, so there's our interest for the third quarter, and now the fourth quarter. October, November, December. So our balance on October 1st is $1,040.40 plus the interest we just made in the previous quarter. So that's $1,061.21. So 1061.21. And we're going to make 8%. And the time is a quarter of a year. So let's see how much interest we make this quarter. So times 0.08. Divided by 4, that's just times a quarter. So we made $21.22. All right, so the question was, how much money will we have after 1 year? So the last day of the year, they're going to take what we had in the account. They're going to deposit $21.22. And that's going to give us $10.61.21, $1,082.43. So we made $82.43 in interest over the year, compounded quarterly at 8%. Assuming you don't take money in and out of the account, which again, that's not realistic. Most people put money in, take money out every month. But that would make it even more complicated. So any questions on that? So it's not too bad for compounding quarterly, but what if you wanted to compound it daily? So now you'd have to calculate the interest you make every day, and if you wanted to do it for a full year, you'd have to do this 365 or 366 times. That's too much. So instead of calculating compound interest manually, which is the way we just did it, we can actually use a different formula. And this is the formula that a bank would really use. Because now, whether you want me to compound it monthly, daily, you want me to compound it every hour, every minute? Sure, I can do that. I just have to change the number in this formula. All right, so one thing that's a little different about the formula is it's not equal to interest. This formula tells you the actual amount of money you would have. It kind of starts out the same, but then it gets a little different. It's the principal times 1 plus r over n raised to the nt. Now the p, the r, and the t, you should know what all those are. P is principal, r is rate, just like we did before. T is time. Again, it's usually in years because your interest rate is usually an annual interest rate. And n is the new letter. N is the number of times compounding occurs in a year. So you kind of have to know what certain words mean. If they say quarterly, you have to know that that means, oh, quarterly, there's 4 quarters in a year. It happens 4 times. Monthly, 12 months in a year, it would happen 12 times. Where people get a little confused, and sometimes I even get confused and I have to look it up, is when you say like bi-monthly versus semi-monthly. There's a difference, right? Bi-weekly, semi-weekly. They're not the same thing. I'm not going to try to trip you up with wording like that. If you're ever not sure what like one of those means, I would tell you. But one of them means twice a week. One of them means every other week. Bi-weekly, semi-weekly. So there's a difference. Okay. Any questions on the formula? So we're going to do the same problem we just did and see if we compound quarterly using this formula, do we get exactly the same result that we got doing it manually. Okay. So our rate was 8%, compounded quarterly, $1,000 in the account. How much money after 1 year? So let's look at our formula. So the amount starts out P, principal. We're starting with $1,000 times 1 plus R over N. 1 plus, now I gotta be careful, how do I write R? It's 8%, but what does that become? 0.08. So it's R over N, and N is the number of times that compounding occurs in a year. If you're compounding quarterly, how many times does that happen? 4 times. Raised to the N times T. Now, this is the part where if I asked you a question about time, like how long would it take you to, and then I said something. If you are ever asked a question about how long it would take, T is a variable in the exponent. You'd have to use a logarithm to solve it. Okay. All right, so let's do this out. Always start with what's in parentheses. Okay. This times 1,000 is going to be the last thing you do, because PEMDAS, parentheses, then exponents. So we get let's clear that, 0.08 divided by 4 gives me 0.02 plus 1. So 1.02. Now do your exponent. In this case, it's just 1 year, so it's just 4 times 1. All right, now we've got that. Now, next thing, finish the exponent. 1.02, this calculator doesn't have it. Now it does. 1.02 raised to the 4th power. And I'm not even going to round that number. I'm just going to keep it exactly the way it is and just hit times 1,000. $1,082.43. If we go back and look at the answer that we got, doing the compounding manually, $1,082.43. So do you really need this formula? No. You could always do it manually. But it really speeds it up, especially if somebody said, well, let's compound it every day. Then you got to do it 300-something times to do it. Where in this case, you just plug in 360 for N and do it out. Okay, now, as I said before, if you compound it faster, it does work out a little better. Like, do I do that next? Yeah, let's do the same thing, but let me compound it monthly. So the only thing that's going to change is N is going to become a 12. And I'll show you the difference in interest you make. All right, so now in this scenario, at the end of every month, the bank gives you the interest you earn, not at the end of every quarter. Okay, so let's look at that. So this would become a 12, and that would become a 12. Okay, so let me see what would happen. 0.08 divided by 12 plus 1. So 1.006 repeating. So let's just go 1.000 repeating. So there's a bunch of 6s. That's accurate enough. Raised to the 12 times 1. So to the 12th power. And the principal stays the same. So that would be the calculation if they compounded it monthly. So let's see what happens. So we've got that number raised to the 12th power times 1,000. So you get 1,080. Actually, that rounds up, $1,083. So is it really a big difference? Well, in this case, it's 57 cents more. It's not really huge. But when you start to get into principals that are maybe in the millions of dollars, somebody that has that much money, then the difference starts to become a lot more. Okay, maybe it could be up to like $100 extra. But of course, at that point, if you have millions of dollars, $100 probably doesn't mean anything to you. So I guess it's all relative. Okay? But the point is compounding monthly is better. Now, if I compounded daily, that would even be a little better. Maybe you make $1,083.06. Make a little bit more. If I compounded hourly, that's even better. If I compounded every minute, every second, it would get better and better. There's actually a formula that's what we call continuous compounding. Continuous compounding basically means the money compounds as fast as possible. It's like you can't even imagine it. It's just the second you make interest, it's instantly in your account, like instantaneously. You don't have to wait a quarter. You don't have to wait a month. You don't have to wait a day. You don't even have to wait a second. Right when you make the interest, it's instantly in your account. And you might think that sounds more complicated, but the formula is actually simpler than the other one. Notice there's no n in the formula. N is the number of times it's compounded in a year. Well, that would be infinity. It's compounded infinitely many times in a year. So we don't have an n anymore. But what we do have is something we saw earlier in the week. E. E pops up here. So it's A equals PE to the RT. This is a formula, I don't know any banks that use this. Nobody really compounds continuously. You might find compounded monthly or daily, but you're not going to find continuously compounded. First of all, the banks would lose a little money, because the faster they compound it, the more they have to pay you. But all the variables are the same, P, R, and T. P is principal, R is rate, just like we always do. T is time in years, assuming your rate is in years. Okay. So this is called continuous compounding. Honestly, I don't think you would notice much of a difference. If you compound something daily, if you compound it 365 times in a year, that's a lot. If you go to continuous, maybe it would be a penny different. It wouldn't really be that much different. And you could try it. Try the last problem again, but let n be 365 and see what happens. Probably wouldn't be much different than using this formula. All right, so we'll do 2 problems with this one, and then we'll finish up. So this one says reinvest $2,000 at 10% compounded continuously. So you got to read what it says after compounded, because that's going to tell you which formula to use. If it says compounded quarterly, daily, monthly, weekly, whatever it says, you're using the other formula. If it says continuously, you're using this one. Okay, so let's write down our 3 variables. Okay, what's the principal here? Well, how much money am I investing in this investment? Luke? $2,000. Okay, and what's my rate? The way that I need to plug it in. 0.1. 0.1 is 10%. Now remember, banks right now are paying 0.15%. It's nowhere near 10%. Okay. And the time, how long does it say we're going to leave the money in the account? Well, Justin? 1 year. So let's see how much interest we could make compounded continuously. A equals, Caitlin, what comes first in this formula?
The
Principal.
principal.
Ethan, what comes after that? E. In my head, I just remember PERT, P-E-R-T. So P-E to the R-T. R-T. 0.1 times 1. right, let's type that in, see what we get. That you can pretty much type in all at once. 2,000 E, 0.1 times 1 is just 0.1. So in this case, you would make $210.34 in interest. For a total of 2,000, what did I say? 210.34. Any questions on that? All right, so the last question, I'm going to ask you a how long question. So let's call that 4A. Let's call this one 4B. So how long would it take to have, let's say, $1,300 if, and now I'll give you a bunch of criteria. You're going to invest $1,000. So invest $1,000. And let's do a more realistic interest rate. Let's do 0.2%. Okay? It's more realistic. Invest $1,000. The rate is 0.2%. Okay. So you know the amount of money you want to have. You know how much you're investing. You know the rate you're investing at. We don't know the time. That's what we're trying to figure out. How long would it take? And let's assume that we're going to do continuous compounding. Okay. So let's assume, because that's the formula we're kind of working on. So assume continuous compounding. All right, so Colby, what's my formula for continuous compounding?
A equals P to the RT.
A equals P E to the RT. Okay, A is the amount of money that we want to have. In this problem, how much money does this person want to have eventually? $1,300. So they want to have $1,300. How much are they starting with? 1,000. E. What's the interest rate here? Yep.
0.002.
Yeah, 0.002. Right? That's very small. And T is the time. Okay. Any questions on that first?
How come it was 0.002?
Because you take your decimal and move it 2 places to the left.
Oh.
So if your percent is 0.2, and you move it 2 to the left, it's 0.002. All right, so my goal is to get the exponential expression by itself. Okay, I want to have something that looks like this. That's the kind of thing we've been looking at all week. Right now, I've got an extra number in front right there. I have that 1,000 times the exponential expression. So how could I move the 1,000 to the other side? Divide it. So let's do that first. Divide by 1,000. And divide by 1,000. It's always the first thing you would do. So now you have 13/10. You could write 1.3 if you wanted. Equals E to the 0.002t. And in fact, I'm going to write 13/10 as 1.3. So then when I have to type it in on the calculator, I don't have to use the fraction bar. That's just easier. So now this is an equation in exponential form. What can we do with an equation that's in exponential form? change it to log. So let's put our log. What's the base on my log? E. Logarithm always equals what kind of number? Exponent, 0.002 t. And then the only thing left is what was by itself. That's the argument. Okay. So last thing I need to do to get t by itself, right now it's t times 0.002. How would I move the 0.002 to the other side?
Division?
What'd you say?
Division?
Yeah, divide by whatever's in front of 0.002. So we have log, actually what's log base e? What's the abbreviation? So it's the ln of 1.3 divided by 0.002. That's how long it would take in years to make $300 at that interest rate. So let's see what that comes out to. It's going to be a very long time. The ln of 1.3 divided by 0.002. It would take you 131.2 years. Basically, you'll never get there in your lifetime. So, interest rates, when you don't have a lot of money, 0.002, not going to make you that much money that quickly. Some other accounts might do a little better, so you got to look for a good account. Okay. Any questions on that? If anybody is interested in that, I do a lot of stuff with investing money and stocks and gold and interest rates and all that kind of stuff. So I do a lot with that. So if you ever had any questions or some ideas how you can make money, feel free to ask. All right, so the homework tonight is 498. It's 3 to 9, just odds. 23, 46, and 50. And on 23, they don't give you the principal, so I'm giving it to you. I'm telling you in 23, let the principal be 1,000. Okay. So we'll take a look at that tomorrow, and then go over it, and we'll have our last test for the class tomorrow. If you need to finish anything up, I will be here for extra help after school today.